Hey everyone, this video explores how to use first in, first out, or FIFO instructions in Proficy Machine Edition version 9.5, and we're going to be using these instruction sets when programming an Emerson RX3i PACSystem Controller. Now, when it comes to FIFO instructions, there's a pair of FIFO instructions when it comes to reading from our tables and writing from our tables, as FIFO instructions basically look at tables of data. Think of a table as an array of data, and in this case we're going to be working with integer data. Now, when it comes to FIFO instructions, we have the FIFO read instruction, which is used to move data out of a table, and it basically uses a pointer that is decremented until, beginning at the highest nth length of our table and just being decremented by 1 every time we remove a value out of our table. Now, values are always moved out of the bottom of the table, and what does that mean? It means values are always moved from the 0th element, and whenever a value is moved from the 0th element, the entire array of data gets shifted downwards. So that means the new 0th element would be inheriting the data value in the first element. Likewise, the second element would then of data would be pushed to the first element, etc., etc. So we're kind of shifting downwards. And basically how it works is once that pointer reaches the bottom of the table, we call that table's empty, and that's it. You can no longer take anything out of the table. Now, when it comes to FIFO write instructions, this is not taking data out of a table. This is actually writing data to our table, and we always move data beginning at the bottom of the table. So what happens is we have a pointer just like our FIFO read instruction, and that pointer, instead of being decremented, is incremented beginning at 0 until it reaches the nth size of our array. So in this case, if we have an array of 10 elements, then it's going to get incremented until it reaches 10, whereupon our table is full. And then that's it. You can't write any more data until you use a FIFO read instruction to decrement the pointer and then put something back in. Now you can increment the pointer by using a FIFO write instruction. So to show you a quick example here, imagine you have an array of 10 elements. These are integers. And if you execute this FIFO write instruction, assuming the pointer is beginning at 0, it's going to write a data point, some sort of integer value, into your 0th element, and then the pointer gets incremented by 1. Then you will now write to the data point to the first element. Then the next time you write to the table, it goes to the second element, third element, etc., etc., until you reach the nth element, which again is the maximum size of your array in terms of how many elements you have. Now, the beauty of using FIFO read and write instructions is you can actually use them together to create what's called a moving window of data points. So you can use FIFO read instructions to take stuff out of the table and then write a data point into your table, because maybe you want a moving window of temperatures or flows or some sort of analog data that's being captured based on your industrial process. Now, what we're going to do is we're going to move into Proficy Machine Edition version 9.5, and we can see here, beginning at the top, all I'm doing to generate my data that I'm going to be filling into my tables is I'm going to be using what's called a service request. And in this case, I'm using service request number 7, and I'm calling my SVC request instruction set to run that request to receive the date and time of my PLC in numeric data format. So this is actually, my service request is actually an array of 9 words, and the first word, I write a 0 to it, and the second word, or the first element in my array, I write a 128 to it, and this means that I'm going to be receiving my data not just as reading the data, as opposed to writing a date and time to my PLC. I just want to receive it. And then the 120 is so that I receive it in numeric data format. And then once I've written to these words in my 9 array of words called SVC request, I'm simply going to call my SVC request function, which is number 7, that's the request number, and then simply pass in the service request array of words. And we can see here, it executes the request, and I get my output in date-time format, and I just simply pass them the respective array elements into other integers, just so I can track the individual elements. So maybe this is my year, this is my month, this is my day, hour, minute, second. And in this case, I'm just going to be using the PLC second, to drive the table kind of entries. So let's just scroll down and let's take a quick look at this. So we can see here every second I'm running a timer, and when the timer executes, later on in our code, I'm going to be filling the table, in this case using a write instruction and also using a read instruction in terms of Fifo instructions to take data out of the table. But we're not going to concern ourselves just yet with a timer, as I want to demonstrate for you the functionality of our Fifo instructions. So what we're going to do is quickly take a look at a Fifo read instruction. Now the read instruction has a few inputs. It has the table itself, which is going to be an array of data. We can see here my data array is in length 10. It's a whole bunch of integers, and it's length 10, and therefore I would write a 10 in the length of my Fifo read instruction. Now that I've passed in my Fifo table, which again is the TB input, I also have a pointer input. And if you recall, the pointer determines where it's going to be reading the data. And in this case, for a Fifo read instruction, data is always taken out of the table at the bottom of the table. And then the Q is simply just whatever was taken out of the table. We can see here from the companion view, this is just the item we've read that has been removed from the bottom of the table. And then on the right-hand side, we can see that this coil energizes as an instantaneous energize, as a pulse, once the table is empty, meaning the pointer has reached 0. So let's go ahead and put some data into our table. Let's suppose I put a data point 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And 10. And let's go ahead and set our Fifo pointer to 10 to start at the beginning of the table. When I execute this pack, normally open contact, I'm going to just, for one pulse using a positive transition coil, write a 1 to Fifo pack to just for one scan, run this instruction, and we'll see that the pointer decrements and 1 is taken out of the table, and then everything else gets shifted to the bottom of the table. Because the bottom, it's not very obvious, but the bottom is the 0th element and the top is the highest element, which in this case is 9. This is a 10 element table. So let's go ahead and let's do that. So I'm going to just run pack. We can see here I've executed pack, this little normally open instruction, normally open contact, and we can see here we've taken out a 1 from the table and everything else has been shifted towards the bottom of the table. So we can see here now the new 0th element is just whatever was in the first element, and the first element now is whatever was in the second element, etc., etc., etc. But what's interesting to note is near the top of the table, we can see here that the highest element is just simply replicated. Now, this is just for the sense of the pointer operation. Whenever the pointer is decremented, values are taken out of the table, but we're never actually putting back values at the top of the table. So what you're going to see is as we decrement our pointer and as we're taking stuff out of the table, you'll see this 10 just basically repeat itself until we're emptied, until the table is completely emptied. So we can see here if I just toggle this pack again, we'll see now the Fifo read onion is 2, and then now it's 3 and 4, and eventually we're almost empty, and now our table is empty. And now the pointer is 0 and the table is completely empty. Now how about filling our table? When we fill the table, the pointer always starts at 0 and then increments as opposed to decrementing, and we basically put a value into the table beginning at the bottom of the table, and the pointer just tells the Fifo write instruction where to write the value. So of course if it's 0, it writes to the bottom of the table. If it's equal to 1, it will write to then the first element and then the second element, etc., etc. So I'm going to write this unpack instruction, and what's going to happen is we're going to run this in the same regard like we did with the Fifo read instruction, except when we call the positive transition coil and we therefore just for one pulse execute this Fifo write instruction. In the same respect, we have the table input, which is again is our array of 10 elements. We have the pointer, which again is shared just like from the read instruction. But in this case, our input is the actual value we want to write to the bottom of the table, in this case starting at the 0th element and then incrementing it upwards. And you'll notice we don't have any outputs because we're not taking data out of our table, we're just writing data into our table. So if I run this pack instruction, you're going to see that pointer increment, and whatever value is shown in our im value here will just be written to the bottom of the table. So let's run it. Okay, we've written a 45. Now the next time we execute this unpack normally open contact and the positive transition coil energizes, therefore we run this instruction just for one pulse, for one scan. We're going to write, let's see, a 1 to the table, or in this case a 2 to the table. I just caught the last second. And now our pointer is incremented again. And in this case, the next time I run this, it's going to now write to the element number 2, or the 3rd value in our table. And there we go, 15, and again, 17, 18, 19, 20, 21, oh no, 20, 22, and this is the last element, 26. And at this point, our table is filled. If I try to write to the table again, I'm just basically toggling this IO. We can see here that nothing's changing. The pointer is reached the nth length of our array. Therefore, we cannot write any more values until we first remove values from the table. So for example, if I were to run my Fifo read instruction to remove 45, let's see if that, there we go. So I've removed 45. Now our pointer is shown as 9, because again, we've decremented using a read instruction by 1. And then at this point, I can absolutely start writing to my table. So in this case, I would write whatever value is in my FIFO value variable. So what is that? That's 14. And now we can see 14 has been written to the top because that was based on the pointer location. Now, as I mentioned earlier, the beauty of using FIFO instructions is you can use a read instruction followed by a write instruction to create a moving window of values. Let me show you that in a second. So we're going to make a few changes to our code here. The first thing I'm going to do is I'm going to remove this pack branch on the FIFO read instructions rung, which will be used to drive our positive transition coil. And in this case, I'm going to remove that always off instruction, because now I want this timer to drive how often I'm moving values in and out of my table, which in this case is every second. And then near the bottom, where we have our FIFO write instruction, because we always remove something first, then we write the next item, I'm going to get rid of my unpack normally open contact, as well as this always off instruction, or always off variable. And now what will happen is, when I accept these rung changes, and I set my, I have to make sure I set my pointer to the maximum value of 10, what will happen is the read instruction will decrement it by 1, and by doing so, it removes the 0th element out of the table. So it looks like I've already done that for myself. And then the FIFO write instruction executes to then write to the 10th element, which will be this guy right here. So we can see when we remove from the bottom of the table, we then replace the top of the table, therefore shifting everything towards the bottom of the table. So if you think about it, the most recent items being written to the table are in the top of the table, and the least recent items, so the oldest items, are actually being taken out at the bottom of the table. So what's really cool is you can, based on this code, you can use a moving window of data, and then based on that moving window, maybe you want to take an average of your data points, maybe you want to track them somehow in some other logic. But the beauty is you have full flexibility of having a moving window of data. And what's very common in practice is using what's called a moving average. You could do a moving average of 100 data points if you really want to, depending on your industrial process and the constraints that are present. So that's how you use FIFO instructions. Again, it's really important that you understand how to use the read instruction as well as the write instruction, because together they can be used to essentially create a moving window of data. Now, you don't have to do it that way depending on your process. Maybe you just want to fill up your table, and then once the table is filled, you then maybe just have some logic run to start removing data from your table, and then once the data has been removed and you use it somewhere else, you can fill it up again. So I hope this video has been very informative and it's taught you something about the FIFO instructions. Thanks for tuning in and thanks for listening.